Hey everybody. So for this week's R lesson, we're going to be building on what we did last week, which is the multiple regression model. So this week, we're going to be learning how to introduce nonlinear variables into that model. So I've already got RStudio opened up here. So let's grab our data set, which in this case is going to be the BRFSS, the Behavioral Risk Factor Surveillance Survey that we used in the first few lectures. So we kind of find wherever that is. And grab it. So I'm just going to use this code here. And of course, before we do that, let's get all of our libraries loaded up. So we're going to need all the usual suspects, tidyverse, ggplot. We'll use lmtest, sandwich, and then finally our newest one, Stargazer. Perfect. Okay, so before even running this, we know from that this data set does have some missing cases. So we're going to want to filter it based on complete cases. And so now let's just go ahead and run all of these things. Okay. All right, so here we have our data. Octave 5, flu shot, doctor visits, etc. Okay, cool. You do notice that we dropped quite a bit of data here. So actually, let's take a look and see what kind of observations are we dropping. Yeah, so it looks like, yeah, missing the ALK day 5 stuff. It looks like doctor visits actually we're missing the most of. Yeah, that seems to be kind of the main culprit in terms of our data loss. And then these kind of two on the right-hand side, physician health or physical health and mental health seem to be actually fairly complete. Okay. All right. So with the remaining kind of 5,000 observations, we are going to be using number of days in the past week that you had an alcoholic beverage as our dependent variable. And we know that this variable needs a little bit of cleaning, right? So it should take values from 0 to 7. But we know that in the past it's taken different values. So let's just check again. Okay. And so, yeah, we have this value 899. There's 26 observations of that. So that one is kind of maybe like a missing value. So we're going to want to drop observations with that. So we're going to take only the observations where ALK day 5 is less or equal to 7. Okay, so good, we'll run that. Dropped a few more observations. The other variables that we're going to want to use in this lecture or in this tutorial are physical health and mental health. So we can see there's a bunch of different values here, 1, 2. So these do seem to be discrete variables. It's really hard to tell what's going on in terms of these values. So for here, we're going to go look at the code book. So when we look at the code book for BRFSS, let's say, for instance, for this last one, MENT health, mental health. So actually this variable captures the number of days where mental health is not good. So if it's a value from 1 to 30, that's the number of days in the past month when their mental health, they said it was not so good. 88 means that there were no days last month where their mental health was not good. So actually that should be 0, right? So 0 days where their mental health was not good. 77 is don't know, not sure. 99 is refused, okay? So we're gonna have to do a little bit of recoding here. So what we're gonna wanna do is use our mutate command, and we're gonna wanna create a new variable, which let's just call, say lower, so mental health kind of written out like this. So we're going to say that that's equal to its original variable value, MENT health, or rather if MENT health is equal to 88, right, then that's the no days of bad mental health in the last month. So we're going to set it equal to 0. Otherwise, we'll set it equal to its kind of value in the data set. MENT health not found. Right, okay, because it's this lowercase thing. Okay, there we go. All right, so that ran. So if we look at that, yeah, so now we have mental health here. Good, so all the 88s have become 0. And if it's 1 to 30 or anything else, actually it's remained the same. So actually we still see that there's 77, which is this don't know, not sure. And there might be some 99s left, which is the, refused to answer. So we will need to do a further filter of DAT where we only keep observations where mental health is less than or equal to 30. Okay, so we've dropped another few observations there. And we're going to do the same thing with this physical health variable. Okay, so basically what we've had here is like a 2-step process where we take this original mental health variable, which can take values from 1 to 30 and then 77 and 88 and 99. And we've turned the 88 values into zeros because those are, according to the code book, 0 days in the past month where you had poor mental health. Once we do that step, then we filter out these remaining 77s. And if there's any 99s, those would get caught too by this line 19, where we only keep observations where it's less than or equal to 30. Actually, I guess this should be less than or equal to 30. Actually, no, it is less than or equal to 30 because in the code book, 30 is the maximum number of days in the past month where you can indicate your mental health was not so good, not 31. Okay, good. So we'll just copy paste this and we'll do the exact same thing, but for physical health, which is this other column in DAT, PHYS health. And according to the code book, let's just double check. It should be kind of the same. Yeah, so 1 to 30 still, and then 88 is none, 77 is don't know, not sure, 99 is refuse to answer. So physical health has the exact same kind of coding structure as mental health. So we'll just use our exact same pieces of code. Perfect. Lost a few more observations. But now what we end up with, we have mental health, we have physical health. It's the number of days in the past month that you felt kind of good about your mental health and physical health, respectively. Perfect. Okay, so now we're done cleaning the data. We can actually start doing some regression. So we'll start out with a simple linear multiple regression. So what we want to figure out with this data set is what is the effect of poor mental health or poor physical health on the number of days per week that you had a drink, right? And one thing I've told some of you in your projects is it's good to have a sense before you run the regression of what the coefficient is going to tell you, and what the sign of the coefficient is going to be. So we expect that the more days in the past month that you felt your mental health was poor, probably the more drinking you might do. So we would expect a positive coefficient. More days with poor mental health leads to a positive effect on the number of days in which you have a drink. And physical health, we might expect the same thing, right? The days in which you kind of felt your physical health gave you or impeded you from kind of doing your normal activities because you were feeling poor, that might affect drinking, right? Perfect. So, but we might expect it to be maybe smaller than mental health, but we'll see in terms of magnitude. So let's do a multiple regression. This will be reg 1, and we're going to regress alpha day 5 on physical health and mental health using DAT. All right. So just to take a look at the coefficients really quickly, summary is fine. Remember, summary will use the homoscedastic standard error, so we don't necessarily want to use it for testing of the coefficients and their significance, but just take a look at the coefficients. It'll give the exact same results because remember, heteroscedastic errors don't change the coefficients. They only change the standard errors of those coefficients. So we take a look and here's what we see. So here's our intercept, number of days on average in the past week. So, okay, we'll come back to that. Physical health has a negative coefficient like we expected. So does mental health. Mental health is actually a lot smaller than physical health. And in fact, it's not significant with these homoscedastic errors. So we would definitely not expect it to be significant with heteroscedastic errors. Physical health is negative and significant at the 5% level. It may still be significant with heteroscedastic errors. Let's take a look. Indeed it is, right? So the p-value has gone up a little bit, 274 to 2759. However, we are still negative and significant at the 5% level. So interpretation time, 1 extra day in the past month. If you report having poor physical health for 1 extra day in the past month, that will lead you on average. Oh, I'm sorry. These are negative. These are negative coefficients. Actually, that's kind of the opposite of what we expected, isn't it? That's kind of the opposite of what we expected. We thought more days of poor physical or mental health would lead to more days drinking, but that's not true. Actually, more days of poor physical health leads to fewer days spent drinking. So that's interesting. And our coefficient interpretation is 1 extra day in the past month where you didn't feel physically healthy would lead you to decrease the number of days per week you have a drink on average by about 0.009. Okay, so about 0.01, right? Okay. So the more days you feel physically poor, actually, the less you're drinking. So that's interesting. And that's robust with the heteroscedastic standard error. Okay, so now finally on to like the content of this week's lecture, which was nonlinear regressions. So we can introduce maybe some nonlinear terms. So maybe what we're thinking is that we should introduce a quadratic, okay? So why might we introduce a quadratic? Well, I'll say in a second, but how do we introduce the quadratic? So what we'll need to do first is create that variable. So we'll say for physical health squared will be equal to physical health raised to the exponent of 2, right? So that's this new little notation. We're exponentiating physical health. And we'll do the same mental health. Perfect. And now to run the regression, we simply include these two new additional regressors. Perfect. So no problems running that. And we can take a look. Oops. This should be squared. All right. Okay, so here we can take a look. And what we can see is that physical health still has a negative coefficient. Okay, the main effect, the physical health squared has a positive coefficient, much smaller in magnitude. That's going to typically be the case when you have a squared regressor. Its coefficient is going to be much smaller in magnitude. And then that is actually positive, and it's not significant, but it's kind of close to significance at a 10% level, which is still quite marginal. Mental health seems to still be having kind of no effect, but we see that the main effect of mental health would be positive if it were significant, and negative for the square. So let's focus on physical health, because there we actually have some significance. So what can we see here? So we can see that for kind of, if you only have a few days during the past month where your physical health was kind of poor, the main effect, like the linear effect, the effect of just physical health, is what's kind of dominant. So it should kind of be decreasing the number of days you have a drink on average. But then as you kind of have more and more days of poor physical health, the squared term will kind of start to take over, right? Because as you have more and more days of poor physical health, you know, you're squaring those days, right? So if you have 10 days of poor physical health, that'll be 100, right? So you'll have 100 multiplied by this coefficient, right? And so suddenly this will actually start to dominate, right? If you multiply this by 100, you're kind of getting rid of two zeros, then you have 0.09, right? So as you get more and more days of poor physical health, actually, this initial negative effect starts to actually become positive, right? Perfect. So the reason why we kind of introduce these quadratic terms is to capture exactly that kind of relationship, right? This idea that, you know, maybe, you know, most people maybe are in good physical health a lot of the time. And if you have a few days of poor physical health, it might reflect that you're sick, you're not feeling so well, so you're not going out, and maybe you're not going out and you're not having a drink, right? Out with your friends or with your family or whatever. But for people who have like systematically poor health, right? Like many, many days of bad health per month, you know, for them, it kind of might be very different, right? For them, they're staying home a lot, they're in pain a lot. So potentially their, you know, alcohol consumption will reflect that, right? So good. When we want to compute sort of the marginal effect of an additional day of poor physical health on the consumption of alcohol, we can kind of just read off the coefficients. It's going to be, you know, negative it's going to be negative 0.034 plus 0.0009 times 2 times physical health, right? So what we've done there is we've basically taken the derivative of our y variable with respect to physical health. We'll get the linear effect on its own, and then we'll get 2 times the coefficient on the quadratic term times physical health, right? Because the derivative of x squared is 2 times x. So that's where this 2 times physical health comes in. Okay. So this is saying that, yeah, there's like this baseline negative effect of an additional day of poor physical health on number of days spent drinking. But as you have more and more days of poor physical health, actually this positive term might start to take over. Okay, perfect. So we have kind of a quadratic shape, but it's a U shape, right? So it's kind of like sloping upwards as x increases more and more. Okay, good. So that's our interpretation of the coefficient. If you want to do a different transformation, so let's say you're interested in multiple regression with logarithmic terms. We can do that too. So I'll just showcase it for physical health. So we'll say log physical health is equal to just the log of physical health, like this. Okay. Run this. Look at the regression. I'm just going to do a very simple single variable regression here. I want to showcase something to you guys. So what's happened? Error in lmfit, NaN in X. And it didn't run. So when we try to summarize it, it says reg3 not found. This is weird. Like our mutation command ran without any incident. Why are we getting this error? What has happened to our X variable? So let's take a look at DAT. Log physical health. Okay, so we have a lot of weird numbers here. We have a lot of decimals, fine, but we have a lot of negative infinity. We have a lot of negative infinity. In fact, it's extremely frequent. You'll notice that negative infinity for log physical health, every time physical health is equal to 0, we're going to get a negative infinity. And that's because looking down in the console, the log of 0 is negative infinity. Okay. So logging a random variable that takes a lot of values of 0, typically not a good idea. You're going to end up with a lot of, so you can run this regression dropping these negative infinities. So instead of using DAT, we could filter DAT and only use observations where log physical health is greater than negative infinity. And this will run. You notice we've lost a ton of observations, right? We're down to 934 from about 4,000. Okay, so that's one thing to keep in mind. When a variable is 0, be it a y variable or an x variable, logging it, you're going to lose those observations where it's equal to 0. However, now we do have like a very strong, significant negative coefficient on physical health, although that could be just because we dropped mental health as a control and we're not including that anymore. So we have a negative coefficient. How do we interpret it? Well, we have a logged x and a not logged y, right? So for a logged x, that means our interpretation is always going to be a 1% increase in x leads to a something. So in this case, the something should be a 1 over, so the coefficient divided by 100 unit change in y. Right? So a 1% increase in the number of days where you report poor physical health is going to lead to a negative 0.0012637 change in the number of days spent having an alcoholic beverage in the past week. So log x, you're going to divide by 100 for the coefficient. If it's not a logged y. If it was a logged y, which we can do, Oh, mutate dat, not day. Now notice we are going to need to do an additional filter. We're going to only use log physical health greater than negative infinity and log alk day 5 greater than negative infinity, right? We don't need to look at the data to know. Some people spend 0 days drinking in the past week. So there's going to be a lot of log zeros there as well. So we're going to want to do the exact same filter as we did with physical health. So we run it, and now we have even fewer observations. We only have 229 observations left once we've gotten rid of all the zeros. And we have a positive insignificant coefficient, but the interpretation here would be a 1% increase in the number of days where you have poor physical health leads to a 1% increase in the number of days in the past week that you spend drinking. Okay, log is not good here for the zeros reason. It's also not great here because, you know, a 1% increase in the number of days last week, like what does that even mean? Do you spend another day drinking or do you not? Like what's the chance of that happening, right? A percent change in a variable that takes so few values, 1 through 7 or 0 through 7 rather, you know, is not terribly useful, not terribly interpretable by your audience. Okay, cool. So that's interpreting that coefficient. Also, you know, we dropped all these observations. And so now this regression output, it's only valid for people who have positive numbers of both days spent drinking and poor physical health, right? So this coefficient is only valid for those people. It's not a simple random sample anymore, okay? Good. So we've got logarithmic terms, we've got quadratic terms. Last thing will be interaction terms. Okay. So for an interaction term, we can actually specify directly in the regression without needing to generate a new variable. So let's say we want to know, okay, we think that physical health matters for the number of days in the past week that you spend having a drink, but we think that it matters differently for, let's say, men versus women. So I think sex 1 equals 1 for women and 0 for men. So this is how we specify an interaction term. We always need to include the base variable that we're interacting with as well. So if you have an interaction term, include both variables on their own as well. We'll run this, take a look. What do we see? We see that there's a negative effect of physical health on days spent drinking. Negative effect of number of days of poor physical health on days spent drinking as before. If you're a woman, you drink a lot less, right? So if sex 1 equals 1, so women compared to men spend half a day fewer in the past week drinking. And then finally, this coefficient here. How do we interpret this? So this is the extra effect of another day of poor physical health for women compared to men. So we can see that if a man has an extra day of poor physical health, they decrease drinking by they decrease the number of days spent drinking by 0.004. But if a woman has another day of poor physical health, she will decrease by negative 0.004 plus negative 0.011. Okay, again, this is insignificant. But what this is saying is that for women, those extra days of poor physical health have an especially negative effect on their number of days spent drinking. Okay, so if we wanted again to know what's the marginal effect of an additional day of poor physical health with this interaction term, we would see that it's negative 0.004 minus 0.0115 using significant digits. Times sex1, right? Again, just kind of taking the derivative of y with respect to physical health so that we're left with the main effect and then the addition of the interaction effect. So when sex1 is equal to 1, you'll have negative 0.0041 minus 0.0115. So in total, negative 0.01191, maybe. No. Yeah. So you'll have the sum of these two things. Actually, why am I taxing my brain like this? Negative 0.0041 minus 0.0115. Okay, very good. Negative 0.0156. And for sex1 equals 0, we'll just have negative 0.0041, right? This extra term, because sex1 is set equal to 0, it multiplies this term, so that term will disappear. So for men, you have poor physical health days. It's going to decrease your drinking by a bit, but not a lot. For women, if you have poor physical health days, it's going to decrease your drinking by quite a lot. Okay, good. So that's our quadratic, our logarithmic, and our interaction terms. Okay. Now, if you want to do all this stuff properly, what you're going to want to do is present it in a Stargazer table. Okay. We'll have text output. And then for our standard errors, we're going to need to add that additional argument, right? So if you ever don't quite recall some syntax, you can always do question mark on the commands. And in the bottom right, you'll see a kind of a help file. And so here, what we're looking for is that standard errors argument. Yeah, so SE. So we'll specify our SE as, again, that's that kind of robust standard error. So we'll do it like we did before. So robust standard error is going to be equal to the square root of the diagonal, the variant, the heteroscedasticity consistent VCO of HC for reg 1. And that's going to be robust standard error for our first regression. And then we do that 4 more times. And just fill in our table. Fill in our list. And here we are. Okay, so our first regression, our simplest one was this one with just physical health and mental health. That was our basic multivariate regression. Our second regression introduced the quadratic terms. So the square terms where we saw it was positive for physical health. And then our third regression included or did this kind of log transformation And notice we dropped all these observations where physical health was equal to 0. So we went from 4,600 down to 936. And our fourth regression, we changed our dependent variable to log ALK day 5. So you'll see that reflected up here, right? Up until now, we'll have had just ALK day 5 for the first 3 regressions. Number 4 is log ALK day 5. And we see it's positive and insignificant. And we have very few observations. And then finally, for ALK day 5, with the interaction term, you can see here's kind of the main effect of physical health. And looking down, we have, here's the main effect of gender and the interaction term. So the extra effect of poor physical health days on drinking for women, right? For sex 1 equals to 1. Okay. And we're back up to our 4,600 observations. Okay. Perfect. So good. That is it for this week. I think this was a bit of a long one, but there was a lot of stuff to cover and look at. I'm sure you'll still have questions after having gone through this. So please feel free this week to come to office hours and to come to the tutorial. We'll do plenty more examples and hopefully we can answer your questions there. All right. Take care, everyone. Bye.